All right, so now we're going to look at what completing the square actually allows us to do. So we start with the problem x squared plus 6x plus 5. And we see that this does not make a perfect square. There's no number that when I multiply, I can make 5, I can add up to 6, and it would be the same factor twice. So yes, it can be factored, but it wouldn't be the same factor twice, so it would not be a perfect square. So what we're going to do is we're going to write x squared plus 6x plus, and we're just going to leave ourselves a blank space, and we're just going to kind of put that 5 out here. We don't really need the 5 right now. We're kind of ignoring it. So now we can go back to what we've been doing in the previous video and on all the previous slides. What number would go right here? When I multiply by itself, I get the number here. When I add it to itself, I get 6. Well, the only number that I can add to itself to get 6 is 3. And 3 times 3 gives me 9. So 9 is what needs to go right there to make a perfect square. Now, I can't just go around adding 9 wherever I want. So if I add 9 here, I need to subtract 9 right here. So what did I just do? I added 9 and I subtracted 9. When I add 9 and I subtract 9, I actually just added 0. So I haven't changed the value of the expression at all, since all I'm adding is 0. Now, this part of my graph, or my expression, makes a perfect square. This is x plus 3 squared. And 5 minus 9 is negative 4. So now I have an expression. These two are equivalent. This one is in standard form, and this one is in vertex form. And I can see that the vertex would be negative 3, negative 4.